and including Brandon now, I have no option but to teach as a class. Is that all right? So we're going to start page 204. This is Pythagoras, and you will locate that on page 204, like I said. Now, this is year 8, but does go a little bit further. How do I get me on top? I can't see me. There I am. That's nice. It's good to see me. Then I know how I look. I want to look cool as well. So that's that. So look at page 204, exercise 1, Pythagoras. So here's a demo that's there, that's on the stuff that I use at school. Yeah, just bring it to yourself. Watch my demo as well. And I've got an opportunity to write using my graphics pen. It does get a bit glitchy, but it's the best I can do. Let's call it up. Yeah, it sort of works. Sort of works. Let's try it. Yeah, it's okay, I suppose. Where's my list gone? Hi, Henry, you're at the top there. All right, so let's just talk you through this then, if I may. Here is a right-angled triangle. You may recall from year 8 that if you take the two sides and square them, you will get automatically the square of the largest side. And there's a diagrammatic representation of that to show how it would fit together as a picture. So look at this. If you designate length A as 3, designate length B as 4, you may recall that if you square the two small sides, you get the big side. So 3 squared is 9, 4 squared is 16, altogether 25. So the area of the square of C is 25. Therefore, the length of the side of C will be the square root of 25, which is 5. Any questions so far? Are you okay with that? Can you all hear? I mean, Brad, just wave. I can see some of you, not all of you. All right. I mean, that's fine. What I'll do, of course, this is going to go on YouTube, so you can copy it when you're ready. Don't copy a single thing now. Don't do page 204, question 1 and question 2. Don't do that now. Wait for this to go on YouTube, and then you can access it and copy the notes. So you need to copy this. So here's the word copy. Let's just rub this little bit out. It will let me. Boom. Rub this out. So just to let you know, you have to copy this little thing. It's glitchy, isn't it? Copy that. So then you can do question 1 and 2. All right. Not difficult. This is the next part of the same lesson. This is the lesson after that. Then there's some higher level stuff up to grade 7. So I photographed this one from your book. You may recognise the graphics, but you can sometimes be called upon to work out the short side. So here's the shortest side, X. I'll do it the long way, and then I'll show you how to do it really quickly in just one step. So remember, the two short sides squared will make the big one squared. Are we in agreement? Nobody agrees. Okay, well, that sounds a bit like sarcastic Ibrahim, but it's his style. So here we go. X squared, I don't know who you are yet. When I add on 12 squared, I should make 17 squared, yeah? Fair enough? Is that okay? Should do, because the two small squares make the big square. So let's do some working out. That plus 144. I should call up my calculator really, because I don't have one to hand. But as you can see, what I have done is got my Casio here, and we're looking at 17 squared, are we? Yes or no? So let's put it over there, I think. So it's 17 squared. Squared, boom, good, 289. Let's go back to our one of these. So 289. So that comes to 289. So x squared on its own is going to be 289. Take away the 144. If anyone got a calculator, then you can help me speed things up a little bit, or I can just do it like this. So minus 144, yeah. 145. Cool. 145, apparently. So therefore, to get x on its own, you square root the 145. Is that cool? And that you can't do in your head because it's going to be just under 12. So anyone got an answer for that? Let's just square root that answer. Boom. Bam. 12.0, it's always 12, okay. I want to go for 12.04 because that's what it says. You can't do decimal places, you can't do decimals with this. There it is, so X is 12.04. Are you good with that? Anyone want comments? Yeah, whoever you are, hello. You're past 202. This is 205. Who am I? Who's that? Anyway, I don't hear anyone else but us. You're not going to hear. So who said they're on page 222? There's too many me's. Anyway, so, all right, so if you're happy to take yourselves forward, you can do that. Can you mute? Could you mute that person so I can teach? Need to mute that person so we can teach. All right, so watch the lesson anyway. If you're up to this point, this is what you need to do. If you've not reached it, this is what you need to do. When we meet up again, then I can teach 1-to-1 as normal or 1-to-2. So either way, all gaps will be filled. So if you're confident to go forward, great. Remember, you do have the answer books because I uploaded it a long time ago. So you've all got access to answers, and then you can get to me if you get stuck, and I'll do a quick vid for you or a 1-to-1. So those of you who are not here, you can then copy this when we're ready. Now, let me show you how to do this in one step. This one over here. Can you see that the X is in fact a short side?
Yes.
And can you see that this 16 is in fact a short side?
Yes.
And that this 21 is the longest possible side. So therefore, I want to show you how to do this in one step so that you can do it like GCSE style. So I want to go straight to X. X is going to be 21 squared, the longest side, take away 16 squared, the short side, and when you square root the answer to that, you will get the answer in one go to the remaining short side. That's fine for GCSE. Now, let me try and demo that. Let's cancel. We're going to go the square root of, and Casio's can handle it, 21 squared, take away 16 squared, and then we're just going to hit it. Bam. 13.6. Let's go for it. 13.6 is equal to 1 dp. 13.6, and it's going to be in centimeters. Is that okay? It's gone a bit glitchy. Yeah. We've got an awful lot running in the background, guys. That's why it's like that. Anyway, you okay with that? Is that all right?
Yes.
Okay, good. What's next? This is a visual picture of why Pythagoras actually works. If you were to create a square of side B and a square of side A, and you put them together, vertex to vertex, vertex to vertex, vertex to vertex, you will find that the area of the B squared and the area of the A squared is in fact identical to the area of the C squared. Not only so, but that will be a right angle triangle. It's just the way that mathematics works. So I said there'll be a visual representation of why Pythag works. That is extending Pythagoras up to grade 7, and there are questions to follow which I've downloaded from a well-to-do maths teacher. So let's just reiterate. You need to copy that demo and do question 1 and 2. Then you need to copy these two demos, the long way, the short way, and go back here and do question 1, 2, 4, 5, 6, 7. I consider these extension-y ones. And here I've called this Pythagoras Plus, which is a lesson in its own right. So for now, let's just reiterate one more time. I've put this on your show my homework. Question 1 and 2 of this exercise. Question 1, 2, 4, 5, 6, 7. I've avoided a lot of the silly questions like question 3 that go on forever. It's just raw triangles. But here there words are involved, and some of these are a little bit tricky because it involves isosceles triangles and stuff, which you've done a year ago. And this is called Pythagoras Plus, where we're going a lot deeper, and then the higher one, extending Pythagoras, is going to be a challenge for some, but we've got to give it a go. Any questions so far about that in terms of what to do? Because we don't have to make it run for half an hour, 40 minutes. You've been launched into the next little bit. Brandon, son, if you're a little bit behind, go back and do it. If you run out of yellow book, just buy a pad of lined paper like I've got. I don't think we need graph paper just yet, but if you want to access some lined paper from somewhere, Amazon it or go into Tesco's, they always have stationery if you can get in, or somewhere. But for now, it's Pythagoras reintroduced. I'm going to shut that bit down and save it.